Welcome back, everyone. We're going to continue those trigonometric functions and that law of sines. And in video 1, we found missing sides, and then today we're going to look at finding missing angles. So our learning target, we're going to understand how trigonometric functions relate to oblique triangles, and we're going to solve some problems. So we're going to be successful when we can use that law of sines to solve those triangles, and we're going to find those missing links and or those missing angles. And we did the links in video 1. In this video, we're just going to focus on the angles. Let's do a quick review on laws of sines and why we use them. So not all triangles are right triangles, and then this is when the law of sines comes in. If we have a right triangle, we can use SOHCAHTOA in those ratios. But if we don't have a right triangle, this is when we're going to use laws of sines. So, nice little triangle. The triangle is not a right triangle. And then we're just going to name it, we'll just go triangle A, B, and C. We know that there's a relationship between angles and sides. So if this is angle A, if I go to the opposite side of the triangle, I have side A. If I go to the opposite side of angle B, I have side B. And the opposite side of angle C is side C. So laws of sines is just ratios. And we discovered in the last video that the sine of angle A over side A is equal to the sine of angle B over B, which equals the sine of angle C over C. And then we kind of pick or choose which set of ratios we need in order to be successful at the problem we're working on. So let's say they give us this little problem and they want us to find angle B. So once I know that they want us to find angle B, when it comes to that ratios, we're just going to rewrite them up here. What was it? The sine of A over A equals the sine of B over B equals the sine of C over C. So since I know that they want me to find angle B, I know I'm at least using that fraction, right? So I would have the sine of angle B over B is going to equal, and now I need to figure out what other fraction I need out of my ratio. So I either need to know something about angle A and side A, or I need to know something about angle C and side C. And it's the C's that I know something about. So then I know I'm using this fraction as well. So I can set those two fractions equal to each other, right? We know, that would be now a C sine C over C, right? So I know that those two fractions are ratios, they're proportionate to each other. So I'm just going to now fill in the information that I know. So sine of angle B is right here, and I don't know anything about angle B, so I'm going to leave that as a B, over side B, which is 9. That equals the sine of angle C. Angle C is 88 degrees over side C, which is 14. I have two fractions that are equal, so I know that they are proportionate to each other. So I can cross multiply these. And so I would have, if I go this way, 9 times the sine of 88. And if I go this way, I got 14 times the sine of angle B. Following so far? All right. So my ultimate goal is to find out what angle B is. So I need to start getting rid of some of my stuff on this right-hand side. So the first thing I'm going to get rid of is 14. And this is 14 times the sine of B. So I know that I can divide both sides by 14. And that's going to, my 14 over 14 is 1. That's going to cancel those out. So I'm now down to 9 times the sine of 88 over 14 equals sine of b. We ran into problems just like this when we were actually talking about trigonometric ratios, and that SOHCAHTOA, that second part of that lesson, was finding those angles. So we need to get angle B all by itself. So we got to try and figure out how to get rid of that sine. And this was when we were talking about taking the inverse, right? So I am technically going to take the sine inverse of this side and the sine inverse of this side, right? If I do it to one side, I have to do it to the other. And we learned in that lesson that if you take an inverse, a function and its inverse, they cancel each other out. They end up being 1. So that's how we get rid of the sine. So then we have b equals the sine inverse. And I make a double set of parentheses, and I do 9. That's a really bad 9. 9 times the sine of 88 divided by 14, right? And I even like throw my numerator in parentheses to kind of help make sure that my calculator doesn't try and do anything crazy on me. We're talking about degrees, so make sure your calculator is in degree mode. I'm going to plug this into my calculator nice and carefully, and I'm going to get to where B is approximately 40 degrees. So if I wanted to, I could even fill that into my picture. And then if I wanted to even expand further, now I could sit there, I could find out what angle A is, because all triangles add up to 180 degrees. I could then continue with using my laws of sine, and I could actually figure out side A as well. So I can use the law of sines to find out a whole bunch of information about my triangles. All right, let's head over to one more example and see if we got this down yet. All right, so just for poops and giggles, I'm going to write down the laws of sine, mainly because I need to practice my penmanship on these little whiteboards. All right. So if I look at the problem that they gave us, they're actually wanting me to find angle C. So if I'm looking for angle C, I know I need to at least look at sine C over C. Now I need to figure out if I need sine of A over A or sine of B over B. So if I look here, angle A, I know something about angle A. Do I know something about side A? Yes, I do. So then I know that I'm going to use sine A. So I know I'm going to use sine of angle A over A, and I'm going to use sine C over C. So I'm going to fill in my knowns. So the sine of angle A, 114, divided by the sine of, side A is 39, equals, and then now I just need my C's. Sine of C, well, angle C is what I'm looking for, over side C, which was, or is, 18. So now that I have my two fractions that are set equal to each other, I can go ahead and cross multiply. So 39 times the sine of C is going to equal 18 times the sine of 114. I'm working on getting C all by itself, so I know I need to divide by 39 on both sides. Right? So now I have sine C equals 18 times the sine of 114 divided by 39. So I'm getting there. So I'm almost got C all by itself, but I got this little sine going on over here. So I know that if I multiply by the inverse and multiply this side by the inverse, function times its inverse, it's going to cancel out. So I'm going to get C equals, and I'm just going to bring the sine inverse out front. And then I'm going to have 18 times the sine of 114 divided by 39. My calculator is still in degree mode because that's what I'm talking about. Oh, to get the inverse, if we don't remember, so on this one on the calculator, you would hit the second sine button, and that'll get you to the sine inverse, right? So I'm going to be careful, and I'm going to plug this into my calculator. And I'm going to get C is approximately 24.9 degrees. Or who knows, maybe that's just 25 degrees, depending on if they want you to round to the nearest whole degree or the nearest tenth. Hope you guys found this video helpful. Make sure you reach out if you need help. I have Remind. You can email me, and I have office hours. I'll talk to you soon. Bye.
Bye.